Okay, picture this. You're running a thriving $10 million annual recurring revenue software company. You're growing, your product is absolutely incredible, but there's a silent leak in your foundation. Every single year, billing errors and legacy systems are leaking $500,000. Think about that. That's $500,000 just vanishing. And we're not talking about credit card fraud here. We're talking failed payments, calculation mistakes, and unbilled usage. It is a stark reality, and it hits the bottom line incredibly hard. And honestly, the cost isn't just financial, right? It's a massive drain on human capital. Just look at this quote from Thomas Stewart at Matamo. To get the features they needed, his team was juggling like 10 to 15 different plugins. That means engineering teams are wasting 20 to 40% of their time maintaining these fragile DIY billing setups instead of actually shipping product features. When your developers are stuck playing a constant game of whack-a-mole with billing bugs, your product innovation just stalls out. Welcome to This Explainer. I am so thrilled to have you here. Today, we're setting a really clear goal. We are going to demystify the transition from those static, old-school subscriptions to highly scalable, event-driven consumption models. We're going to look at exactly what it takes to build automated billing software for 2026. Here is our roadmap for today. We'll start with the 2026 billing crisis. Then, we'll unpack the event-driven core architecture, look at real-world scale using Twilio, tackle multi-tenant databases, review security and PCI compliance, and finally, weigh that ultimate build versus buy decision. All right, part one, the 2026 billing crisis and why legacy systems are just failing us. Look at the sheer contrast here between then and now. Back in 2020, billing was heavily subscription first. You had your static monthly charges, predictable seat counts, simple renewals. The systems were built for these rigid, batch-processed cycles. Fast forward to today, 2026, and the landscape has fundamentally shifted. AI workloads and usage-based models are generating literally millions of usage events per customer. We're dealing with variable AI tokens, real-time metering, prepaid credits, the whole shebang. When you try to force that high-volume variable data into a rigid 2020 architecture, the system just breaks, and suddenly your billing becomes massive technical debt. Moving on to Section 2, Events-Driven Core Architecture. This is how we build a robust foundation. You see, modern billing isn't just one single action anymore. It's a complete workflow. It relies on 5 interconnected stages. First, usage metering captures and aggregates raw events in real time. Second, the rating engine applies your complex pricing logic, things like tiers and discounts, to convert that usage into actual charges. Third is invoicing, combining subscriptions, usage, and taxes transparently. Fourth, payment orchestration handles the actual collection. And fifth, reconciliation syncs it all back to your accounting software. If any one of these stages is handled manually, your entire system is incredibly fragile. Okay, let's dive into this and trace how a high-throughput transaction engine actually works under the hood. Up at the top, you've got your event producers. That's your application generating the data. Notice how they're completely isolated from the downstream processing. They feed raw data straight into the event broker, typically Apache Kafka, which uses partitioning to handle massive ingestion with really low latency. Kafka is essentially your scalable buffer. Then, the stream processing engine, something like Apache Spark, draws those events to run the calculations before passing the data on to the billing APIs. It's this decoupled modular design that lets you scale up without crashing your core application. Now, here is a massive trap you absolutely have to avoid in that event stream: duplicate processing. The magic word to fix this? Idempotency. Look, when a network connection drops, systems naturally retry sending data. If your billing system doesn't use unique idempotency keys to ensure each event is processed exactly once, those retries turn into double charges. Without it, duplicate processing can easily inflate customer invoices by 5 to 10% at scale. And let's be real, nothing destroys user trust faster than overcharging them just because your network hiccuped. Section 3, Real-World Scale. Let's look at Twilio's architecture. And this brilliantly illustrates what we've been talking about. Notice their stream processing layer. They utilize Apache Spark's structured streaming to read from Kafka topics. Twilio processes billions of daily transactions, SMS, voice, video, all with near zero latency. Because of this separation, their ingestion and processing functions operate totally independently. So if there's a massive global spike in text messages, Kafka absorbs the shock, and Spark just scales up its processing nodes to calculate the billing without dropping a single event. So what's the secret sauce inside that Spark layer? It's microbatching combined with stateful transformations. Instead of just looking at events in isolation, maintaining state across these tiny, continuous microbatches lets the system remember what just happened previously. This is exactly how Twilio tracks cumulative usage to apply complex logic, like dynamic volume discounts on the fly. Say your price drops after 10,000 API calls. Stateful transformations are what alert the system the exact millisecond you hit call number 10,001. All right, Section 4, Managing Multi-Tenant Scale and Your Data Isolation Strategies. So the crucial point here is choosing the right isolation strategy for your SaaS. You essentially have three main options. First is row-level isolation, where all tenants live in the same database tables, but they're filtered by a tenant ID. It's really common and simple, but it requires strict discipline. I mean, one missing filter in your code and you've got a catastrophic cross-tenant data leak. Then you have schema level, where everyone shares a database but gets their own schema, kind of like a great middle ground. Finally, database-level isolation gives every tenant their own distinct database. Maximum security, sure, but the operational overhead is huge. For billing, most teams scale up using strictly enforced row-level isolation, but you have to make this architectural choice early. Section 5, Security and PCI Compliance. The absolute non-negotiables. Adhering to PCI DSS version 4.0 is mandatory, no way around it. Here are three absolutely critical steps. First, isolate networks using firewalls. Keep your cardholder data completely separated from everything else. Second, and this is vital, implement immutable logging. By using centralized time sync like PTP or NTP, you ensure every system shares the exact same millisecond timestamp. This creates a tamper-evident, immutable audit trail that forensic investigators rely on if a breach ever occurs. Finally, you have to rotate your cryptographic keys and API secrets automatically, using short time to live or TTL settings. If an attacker gets a key, it should literally expire before they can even figure out how to use it. Finally, Section 6, the build versus buy decision. So now that you've seen the sheer complexity of what it takes, we're talking Kafka, Spark, stateful processing, PCI compliance, idempotency. Should your engineering team actually build this? Let's systematically weigh the trade-offs. Building your own gives you unlimited customization, for sure. But the time to market is measured in months, not to mention the ongoing engineering maintenance you're signing up for. On the flip side, using an external API or infrastructure provider drops your time to market to just weeks. Plus, an external partner instantly handles the grueling tax compliance, PCI regulations, and automated dunning. Yes, buying external has a higher per transaction cost at scale, but it keeps your engineering team focused on building your actual product. To break down the decision framework, you should generally only build if you have over 10 million in ARR, possess highly unique custom pricing models that literally no provider supports, or if you face super strict in-house regulatory mandates. Conversely, you should almost certainly buy external infrastructure if you are pre-product market fit, have a team of under 20 engineers, or if you're selling globally and need to navigate international tax jurisdictions. In most cases, external infrastructure prevents diverted engineering focus and incredibly costly leaseholds later on. I want to end this explainer with a provocative question for you to chew on. Where will your transaction volume be in 24 months? The biggest mistake companies make is choosing a billing infrastructure for where they are today rather than where their growth is taking them tomorrow. If you expect to scale into millions of events, AI tokens, or complex hybrid pricing models, you need an architecture designed for the future, whether you build it yourself or partner with a provider. Thank you so much for learning with me today, and keep building for the future.